In this video, I will be explaining how to check carbon monoxide levels in a furnace flue using a combustion analyzer. In my demonstrations, I'll be using the UEi C161 analyzer, and I'll be checking the flue levels of this furnace right here, which is a two-stage 80% furnace. And then after that, I'll also check the readings on a high-efficiency 90% furnace as well, just to see how the numbers compare. Now, there are many varying opinions on how this should be done and what the actual readings should be, and I definitely don't claim to know it all. So if you're a technician watching this and you have your own opinions or suggestions, your comments are very welcome in the comment section below. As for me, I'll simply be showing you how I do it and what I've been taught throughout the years. So that being said, let's begin. I'm going to go ahead and plug in my test probe into the analyzer, and just so you see what I'm doing, here's the port for it. You plug in the tube here. It has the little rubber gaskets to prevent any leakage. And then you have two K-style ports where you put your temperature adapter into. And I'm only going to be using one, but later in the video I'll show you why there's two of them. And then there's also a micro USB port right there because this analyzer does have rechargeable batteries. So let's fire this analyzer up. And like most other analyzers out there, it has a 60-second purge cycle, which really should be done outside in fresh air. On the bottom here you see the time, then the battery life remaining. And while we're waiting for it to purge, just quickly about the meter, you got the navigation and the function buttons right here. You got the menu options right here that you can select with the dial. Then there's also a little sight glass on the bottom over here. So whenever the water trap fills up with water, you can see it from the front when it gets too high. After it's filled up, you can open up the plug in the back and dump that water out. And my favorite part, of course, is the magnets in the back. Any meters or analyzers that have magnets in the back, just like the UEi meter I have here, I'm definitely friends with them. Okay, so it's done purging, and just so you have a rough idea of what calculations and readings this analyzer can make, I'm just going to quickly go over all the menus over here on the dial setting. So right now it's set to general settings, and that's nothing too interesting. You can just change the date, the header, infrared printer, you can change between Celsius and Fahrenheit, gas units, what language you want to use, efficiency, what O2 reference you want to use, logs, it can store up to 30 logs, you can put a password on it, and general settings like that. And if we go to our next menu, which is the status menu, this menu just shows us that the analyzer is set to natural gas. TI stands for the ambient temperature, so it's 70 degrees in the room right now. ATM is the atmospheric pressure, which is 978 millibars. Cal is just for calibration, that is due in 340 days. There's the clock, it's 2:57 right now. The stop, which just means that the pump is stopped, it's not running, and how much battery life remains. Our next three settings on the menu are AUX, Flue 1, and Flue 2. And whenever you switch to any one of these three, the pump automatically starts. And let's just start with Flue 1. There you go, the pump fired up. And I'm going to go ahead and pause it for now by hitting and holding the pause button. So CO2 is for carbon dioxide, O2 is for the oxygen, EFGC is efficiency, gross calculation, T1 and T2 are temperature 1 and temperature 2. The reason I don't have temperature 2 showing up here is simply because I don't have the second temperature adapter plugged in, and I usually don't use it. So that's the first menu, and we'll see these numbers filled in after I actually fire the furnace up. Our next one is Flue 2, and the reason they're separated is because they have different readouts. Pause it again. Our second screen has CO for carbon monoxide, COA, and I'm not quite sure what the A stands for. If you resume it, if I had to guess, COA just means that if the analyzer is reading over 200 parts per million carbon monoxide, an audible alarm will sound or the meter will start to beep to notify you that the carbon monoxide levels are getting high. CO2 is carbon dioxide, loss is for heat loss calculation, X-air is for excess air calculation. And then AUX is the same as Flue 1 and Flue 2, except you can actually modify what readouts it shows you. So each one of these lines you can change. So if I didn't want O2, I can put carbon dioxide here, or heat loss, or whatever. So on my OGS, I have it set up to oxygen, carbon monoxide, carbon dioxide, stack temperature for T1, and efficiency. And out of all of these readings, the carbon monoxide, of course, is the most important, because if that is really high, then people can die. The other readings have more to do with the efficiency, but they are also important because they directly affect the carbon monoxide levels as well. And our last menu is temperatures. There's T1 and T2. That's if I had the second one plugged in. And this is delta T. So if you do have both of the temperature adapters plugged in, this third line right here will show you the difference between the two to give you the delta T. Okay, so that's the brief overview of what this analyzer can do. Now let's actually go ahead and drill a hole in my vent and fire the furnace up and get some real readings going. Okay, so here's my furnace venting, and before I'll be able to put my test probe in there, of course I have to drill a hole in my vent. Now for my vent, which is a type C single wall vent, that is okay to just drill a hole right in it. But if you have a double wall type B venting, it's bigger and it has two walls to it, you should not be drilling holes in that one. And if for some reason somebody drilled a hole in it before you, the best way to seal that up would be with some high temp silicone. So just squeeze some silicone in there and then cover it up with some aluminum tape or some sheet metal tape. So type C single wall venting is okay to drill right into, but type B double wall venting is not okay. Luckily, most of those type B vents, they have an adapter on the bottom where it transitions from a type C into a type B. So on the bottom section, right where it comes out of the furnace, usually it starts out with a single wall and then goes into a double wall. In that case, you can just drill it right in that transition or that adapter and take your reading from there. So typically I drill a hole about somewhere from 6 to 12 inches from the furnace in the vent. So I'll just drill a hole right over here. And the size drill I picked is just slightly bigger in diameter than my test probe. Let's go ahead and see if my test probe fits now. And as you can see, it just goes right in. And the purpose of this cone right here is so that you have a set measurement. So if you're doing like furnace tune-ups all day long, you can just set this to a set measurement like right here. Or if you're taking it in and out. And of course, it'll only go up to that cone right there. And what I like about this testing probe is that they made these little divots on the top and the bottom, which is really slick. It prevents this cone from falling off. So it prevents it from going too low, and it prevents it from going too high or falling off of the test probe. And of course you got the little tightening screw to set it in place. So anyways, we have our hole drilled. Let's just turn on our furnace and get some readings. So the furnace has been running for a couple of minutes now, and optimally to get an accurate read, you do want it to run for about 5 to 10 minutes before you get your reading or before you put your probe in. So I'm going to go ahead and turn it to AUX, which is what I usually use, my custom menu. The pump starts right away. And I've mentioned this before, but this is a 2-stage furnace. So after about 15 minutes of runtime, this furnace will shift up to the high stage, and my readings should change because the gas pressure goes up and the inducer motor speed goes up as well. So let's just see what we have for my low stage reading. After about 2 minutes, the numbers have stabilized. My oxygen is at about 12.6%, and typically on most inspections and checkups that I do, the oxygen is between 8 to 12%. It's a little bit on the high side, but I'm not worried about it, especially since my carbon monoxide is at 15 parts per million. If the carbon monoxide is below 50 parts per million, you're pretty much good. Carbon dioxide is typically between 4 to 8% is what I see. It's on the lower side, which is good. That just means it's burning clean. And my stack temperature, or my exhaust pipe temperature, is steadily climbing, which is normal as well. For an 80% furnace, around 300 degrees inside of the exhaust pipe, that's a pretty normal reading. And my efficiency calculation is at about 78.8%. And being that it's an 80% furnace, that's actually pretty good. Okay, so now my furnace kicked into high stage just about 5 seconds ago. And as you can see, the numbers are changing pretty rapidly. Once again, I'll give it a minute or two to stabilize, and we'll see where the numbers end up. And while we wait, just a couple things I want to touch on. So what is the allowable carbon monoxide levels going out the furnace flue? And the answer to that is, according to AHRI, if the carbon monoxide emissions are 200 parts per million or lower, no further action is needed. So anything under 200 is acceptable. Most companies, if the carbon monoxide gets to 100 parts per million, we would do a little bit further investigation, maybe check the gas pressures, make sure there's enough intake air, check the burner restrictors, see if anything's going on there, maybe clean the burners. If the carbon monoxide is getting to 200, then we for sure need to do some investigation, because there's definitely something going on that's causing the carbon monoxide to go higher. And just so you know, newer furnaces generally have lower carbon monoxide levels or carbon monoxide emissions, whereas older furnaces generally have higher levels of carbon monoxide. So it's been about 3 minutes, and the number's pretty much stabilized. My oxygen levels dropped. Carbon monoxide surprisingly went down. Normally, I usually see it go up on the high stage, but going down is great. That means the furnace is actually burning very clean in its high stage. Carbon dioxide went up a little bit, and my stack temperature, or the temperature of my vent pipe, went up as well, up to 400 degrees, which is once again pretty normal for an 80% furnace. If you have an atmospheric draft furnace or a 70% furnace, the stack temperatures can get up to 500 or 600 degrees. And the efficiency stayed pretty much the same at 78%. So from these two readings that I got on my low stage and my high stage, I can safely say that my furnace is burning cleanly and it's running safely. And that is how one would go about checking the carbon monoxide levels in the furnace flue. Now, one more thing I want to mention is that when you're checking the carbon monoxide, really pay attention when you just stick your probe into the flue pipe. Really pay attention to the CO levels and see what they're doing. If you see the CO levels going up really fast, if you have a cracked heat exchanger or a plugged secondary heat exchanger, you're going to see your CO levels just skyrocketing. So it'll go from 5, 30, 90, 150, 300, 500. And if you see it climbing that fast, it's like every single second it goes up by about 150, pull out your probe immediately. If you leave it in there, that can peg your meter and pretty much destroy your carbon monoxide sensor, and then your analyzer will be out of commission until you get that fixed. So don't leave your probe in there if you see your carbon monoxide just skyrocketing. Don't try to set any records. So once we're done getting our readings, the last thing you want to do is patch up the hole that you drilled out in the vent pipe. Some people use the high temp silicone. I prefer to just use the sheet metal tape and put it on there nice and tight, or nice and snug, or whatever you want to refer to the tape as. And because this analyzer does not come with a printer, I mean, it's capable of communicating with an infrared printer, but it does not come with one, which is okay considering that it costs 2 or 3 times less than most of the analyzers out there. What I like to do is to just put L, that's going to be for my low stage, and then H for my high stage. Low stage was 11 parts per million. High stage was, I believe that was ended up at 4 parts per million. And then as a finishing touch, you can add the date. That way, if you're going to do annual furnace inspections, you can see what was going on last year. And if you really want to, you could add your initials. I usually don't. I just add the parts per million and the date when the readings were taken. Okay, so now we're at a high efficiency furnace, which has plastic PVC venting. It also has an intake pipe. And if you're not sure which pipe is the intake and which is the exhaust, if you just take the top door off, that's going to be pretty easy to tell. Basically, the intake pipe is always going to be going to your burner box to provide the oxygen for the flames, whereas the exhaust pipe is always going to be going to your inducer motor, exhausting the combustion fumes. And as you can see, the gas valve says high and low. The inducer motor has a red and a black speed. That means that this is a two-stage furnace as well. And I do have one more tip about the exhaust pipe, where to drill the hole on it. And on this furnace, the hole where we're going to be sticking our test probe into was already drilled out previously by somebody, which is okay. But I do want to talk about this just a little bit. I'll take this off later, I guess. But basically, where you want to drill the hole is the opposite side of where the water will be flowing. And what I mean by that, high efficiency furnaces, they condense, they create water. So there's going to be water that is constantly, slowly running back down this pipe. The high efficiency furnaces, the exhaust pipe is on a gradual downward slope towards the furnace. So there's always going to be some water trickling down the inside of the exhaust pipe. So if we look further upline of the exhaust pipe, right here. Over here, it just basically goes outside and out the wall, but it goes down into a 90-degree bend, and it turns down, which means the water flowing down is going to be going down this side of the pipe, most of it. So it goes down, and then if you just kind of follow it, it'll go down on this wall, and it'll trickle mostly on this side. So you definitely don't want to drill a hole on this side. So in this case, you would want to drill the hole somewhere on this side, and preferably, I don't know, maybe like a foot away from the furnace itself. This is a pretty good spot. So in a nutshell, you just don't want to drill a hole where the water is going to be running down. So let's take this piece of tape off. Okay, so we got the tape off, and one more tip about drilling a hole inside of the PVC pipe. You want to angle it down. I mean, even though the water is mostly going to be on this side, there will still be some moisture on the other side of the pipe as well. So when you're starting to drill the hole, just drill into it a little bit. I'm not going to drill another hole since this one already has it, but you basically drill into it a little bit, and after your drill is sunk in, then you angle it downwards to finish up the hole. That way, you know, all the moisture, or most of it at least, is going to go right past the hole and around it instead of coming out of the hole. So let's put the door back on and fire the furnace up and take my readings for the low stage, and then I'll wait for it to go into the high stage and we'll take another reading on the high stage. Okay, so the furnace has been running for a couple of minutes now, and I already have my analyzer fired up. Let's stick my probe in and see what kind of readings we get on a high efficiency furnace. As you can see, the oxygen levels, or the oxygen percentage, is dropping down pretty quick, whereas the carbon monoxide is going up pretty slowly. So not a lot of carbon monoxide is being pumped out by this furnace. The carbon dioxide is about 5.4. I'm sure that'll change a little bit. And also the temperature of the flue gases in a high efficiency furnace are much lower than that of a standard 80% efficient furnace. I'll give it a couple of minutes to completely stabilize so we can see what our final numbers are for the low stage. It's been about 2 minutes now and the numbers pretty much stabilized. 11% for the oxygen. Those are pretty normal levels. That's what I usually see for high efficiency furnaces. Carbon monoxide, 11 parts per million. That's actually very good. That's pretty low for a high efficiency furnace. A lot of times I'll see it somewhere around 35, 40, 50 parts per million. Carbon dioxide, that's pretty normal as well. Typically on high efficiency ones, I see it somewhere between 5 and 7%. And a 99.2 temperature inside of the exhaust pipe is pretty good as well. And this is low stage. Once this kicks into high stage, the temperature should go up. And I'll wait for it to kick into high stage so we can see that. Oh, and I almost forgot, instead of T2, because I don't ever use it, I usually have the efficiency instead, gross calculation. So our gross calculation for efficiency is 96.3%. So for a high efficiency furnace, that's actually very good, 96% efficient. And while we're waiting for the furnace to kick into high stage, I just want to show you quick how I change that. So I pause it, and then if you scroll up until you see edit, you press and hold the middle button, and you're able to edit any of these lines and get whatever value you want. So, for example, this is the line I switched right here. If I scroll up or down, I can pick whatever I want. I can pick the atmospheric pressure, the ambient temperature, temperature 2, temperature 1, oxygen, etc., etc. But in my case, I want the efficiency, so let's find that again. There it is. Press the center button, and voila. And then we can resume our pump. And we're back in business. And once again, still waiting for the furnace to kick into high stage. Okay, so the furnace finally kicked into high stage. And as you can see, the numbers are starting to change now. Now that the gas pressure has gone up, the inducer motor has gone up in speed as well. Let's see how this affects our numbers here. So the oxygen is going down, carbon monoxide is slowly going up, the carbon dioxide is slowly going up as well, along with the temperature, and our efficiency dropped a little bit when we kicked into high stage. So it's been a couple of minutes and the numbers are fairly stable now. Oxygen went down to 7.62. Surprisingly, the carbon monoxide actually went down to 9 parts per million, which is unusual. Typically the carbon monoxide goes up a little bit, not down. But that's good. 9 parts per million in high stage, that's very good. Carbon dioxide, 7.6%, that's normal. And the stack, or I guess in our case the exhaust pipe, the temperatures inside of that went up to 109 degrees. So about 10 degrees higher, which also is normal. And our efficiency ended up at about 94%. So that is a normal read for a high efficiency furnace on high stage. Okay, so we're done here. Let's take out my probe. And be careful about grabbing the tip of it, especially if you're measuring this on a 80% furnace, because this will be super hot. Granted, from a high efficiency furnace, it only got to 120 degrees, so it's not too hot. But other than that, if you're measuring it on a low efficiency furnace, you will burn yourself if you grab this. So take this out, and typically I like to let my analyzer cool off completely, or zero out, before I turn it off. It does have a little purge cycle when you turn it off. It gives it 10 seconds before it completely turns off. But I like to let it actually purge out completely before I power it off. So I just leave my analyzer on, and then to turn off my furnace, I like to just turn off the gas to the furnace first. That's if you're not just going to turn it off at the thermostat. So typically after I check my carbon monoxide and all of that, if I'm doing a furnace inspection, I turn the power off and I take the furnace apart and start looking at components inside. So to turn it off, I turn the gas off, I leave it off for about 15 seconds or so, 20 seconds, I let it cool off a little bit before I hit the power switch. Turn it off, and I can turn the gas back on so I don't forget about it. And about the hole. So some people say that you're only supposed to put some silicone in there and then cover it up with tape, or just the silicone. Let me turn off my analyzer now so it's not buzzing in the background. See how it says turn off, goodbye, purging. It started at 10 seconds. Boom, turned off. Okay. So personally, I always tape these holes, even on high efficiency furnaces, even though it condenses and there's water. And I'll tell you in a little bit why. By the way, I always keep a piece of sheet metal tape in my pocket at all times. I just roll it up and have it in my pocket because having sheet metal tape on you is always really handy. So I rip off a small piece. This is how I do it. I mean, some technicians, it kind of bothers me when I see this, but they just kind of slop it on and voila, they're done. That's when they start to leak, when people put them on like that. Then yeah, of course, you're going to have streaks of water coming down because it's on really sloppy. What I like to do is I put it on and then I press down into the hole, wherever the hole was. I make sure that the hole is really nicely sealed, so you can see the outline of it all the way around. And then after that, it's neat, plus it's a very good seal. I take a nut driver and I just rub on it on all sides like that, so it completely sticks to the PVC pipe and it makes a good seal. And if you do this, even if this sheet metal tape dries out and becomes brittle, it's not going to leak anything through. At least I've never seen it leak anything through. When you have it sealed up this nicely, that's really all you need to seal up that hole. Well guys, and that is how to take the carbon monoxide reading along with other readings on the furnace flue using a combustion analyzer. And since there's a water heater right next to me, why not? Let's take some readings on that as well. I already have the temperature turned way up to very hot. That turned on the burner, and it's been on for about 2 or 3 minutes now. So we are ready to check what kind of emissions that thing is producing. And since this water heater is atmospheric draft, meaning it's pulling in oxygen just from the room here, I don't have to drill any holes. I can just stick my probe right in the middle of that vent pipe or the flue and wait and see what kind of readings I get. There you go. My numbers are dropping. And from what I've seen, water heater carbon monoxide emissions are generally very low. So I'm not surprised to see it at only 2 parts per million, which means it's burning really clean. So for a water heater, it is kind of strange if you're going to have parts per million going up to 300 or 400. That probably means that the burner is either really dirty or the intake screen on that water heater is really plugged up. So my numbers are pretty much stabilized. They're still fluctuating a little bit. Oxygen is at 8%, carbon monoxide 2 parts per million, carbon dioxide 7.3, and the stack temperature is at 550 degrees, which is pretty high, but it is normal for an atmospheric draft furnace or water heater, which is typically somewhere between 500 and 600 degrees. And the efficiency is not bad either. It's at 75%. Well, anyway, that is it. I hope you found this video useful. If you have any further suggestions or corrections to anything that I said, or just some feedback about what you saw in this video, please leave that in the comment section below. Thank you so much for watching this video. Don't forget to mash that like button on the way out, and I'll see you next time. And if you're still here and not in the comment section below, help me out with something. What is the correct way of saying this? The yolk of the egg are white, or the yolk of the egg is white? The answer is neither one. The yolk of the egg is yellow.